Hello everyone, I am Andrew Julian Putra Pertama Hanusa from Level 8 Computing Year 2, and I'm here to explain you about the project of Mathematics 2 in my Year 2. And we are tasked to do a screen assignment about motion, parametric equations and motion, and we have the certain tasks to do, and I have all wrapped up in here. And this is my task 1 first. So in task 1 we should do do this problem and how to create the 2D movements using the parametric equation, and then you can also explain on how do you create a straight line motion, how do you create a wave type motion, how do you create a circular motion. In circular motion, how do you control the radius, center, speed, and point and direction. So for the start I will show you on how to create the following 2D movements of the parametric equations. So first, let's work on the problem first. An object moves in a straight line and a constant speed from the point 2 and minus 4 when the time is 0 and to the point of 12 to minus 24 when 5 seconds later. So first we work it out on the equation, and it's a equation of a line which is y equal to mx plus c, which y is the position of y, m is the gradient, x is the position of x, and c is the constant. So we find m by finding the differences between y divided by the difference of x. So we can now see from my calculation, and the gradient is 2.8. From this 2.8 we put in the value of the position, which is 2 and minus 4. So minus 4 equals to 2.8, which is the gradient, times 2, which is the x, plus c. And we get the c equals to minus 9.6, and we can get the y that equals to minus 2.x minus 9.6. And then we get the position of time, which is t, comma 2.8t minus 9.6, because we change this x into t. And then speed equals to distance over time, so it will be 10 divided by 5, which is 2. And then we can get that x equals to 2t plus 2. And the equation is just pt equals to 2t plus 2, comma 5.6 5.6t minus 4. And then we make it into graph. First we get the t, which is from 0, 1, 2, 3, 4, 5, the 5 seconds. And then there's the 2t minus 2, which is 2, 4, 6, 8, 10, 12. And you can get the x value and the y value, which is 5.6t minus 4, which is minus 4, 1.6, 7.10, 12.8, 8.4, 424. And you get the graph, which is like this. This graph shows a constant increase of speed over time. I mean the distance over, yeah. So they covered like this. And second object, which is if an object is initially at 7.2, it takes more 30 seconds to complete a circular motion of radius 4 about the center point of 3.2. So we can get the value, which is 4 cos 3t and 3.4 sin 3t plus 2, which is cos is the x and sin is the y. Because x you can get cos, which is cos equals to adjacent, so we are searching for the adjacent one, and sin is the opposite over tangent, so it's sin is y is the opposite. So you can get this value by taking from 0 to 360 degree, and we take for a definite more detailed circle we make from with 30 degree to 3 degree, and from that we can now get the circular motion. And it's a motion, but it's how we visualize it in the graph. So, and how do you create a straight line motion? From here we can see that the differences are quite we can see. So in a straight line motion, there's no x and the y are not having powers, so it's just to the power of 1, and if to the power of 1 the line will just go straight, like y equal to mx plus c, so x equal to 2t plus 2, y equal to 5.6t minus 4, it will create a straight line when it's being incorporated. While in a wave type motion, it's usually to the power of 2. Or you can see like in a graph, if you try to x squared plus 5x minus 2, it will create a y equals to that equation, it will create a graph, which is a type of wave. While in a circular motion, it usually consists of cos and sin. And the cos and sin, cos represent the x value and sin represent the y value. So we can see how they create a straight line motion. We can explain more from this graph. You can see that y equal to 3t. This is there are questions that can explain you that an object over time. An object over time example, yt equal to 3t and xt equal to 2t over 5. We can draw a graph like this, and then there's a graph, straight line graph, and then there's a graph like this. There's a circular motion graph like this. This is a wave graph, circular motion graph again. So as you can see for the difference, you can see from this value that the x and the y have no powers. So you can see that this will just go make a straight line, and this one is just act as the cos, so it will make a very tiny range of x value, which is from minus 1.5 to 1.5, and is even smaller from minus 1 to 1, since cos is just from minus 1 to 1. And then there's yt, which is equal to 8, which obviously no matter what is the t, it will always be 8, so it will make a straight line. This is the value what's here. That's so that what we plot. And in this graph, you can see that it's a quite a wavy graph, but it's not really a wavy graph. It's just because you pointed in a cos graph, so it will create a wave like that. And this is the circular motion where x is sin and cos is sin as well. It will create a circular motion since they are all 0 to 1. As you know, that sin 0 equal to 0, sin 90 equal to 1, and then you can just go on and on by that, and it will just cos as well, cos from 1 to 0, so it will create a circular motion like that. This is same as well, but it just go twice when if it's 2 sin t and 2 cos t, while this is a sin t and 1 sin t and 1 cos t. What's the difference is the size is bigger, since if you can see this from minus 2 to 2, while this one is from minus 1 to 1, so this 2 represent how the difference, how it's like multiplied, so the size is getting bigger times 2. This one gives the difference of the angle, which is the angle are times by 3 within a 2 size circular motion, while this one is also by 3. As you can see, the angle, the circle are quite different. There's the one that is more sharp angle, and there's a more wide angle. And this one is a 4 sin t and 4 cos t. As you can see, it starts from negative 4 into 4, so you can see it's bigger, and this one is as well. This one, if you create a different x and a different y, you change it, and if you change it, what will be created is not a circle, but it's more like an oval, since it's more longer, not a bigger one. And if you make a cos t plus 3 and sin t minus 3, what will be created is it's not a circle that is origin at 0. It will create a circle that's origin in 3 and 3.3 axis. So what is being created is this is the 3.3. So it is the origin, and you can see the circle that is made in the origin of 3.3. And 1.2 cos t minus 1 and 1 plus 2 sin t will be created create a circle like this, and this is probably the not a wave, but yeah, pretty similar to a wave, since the line is different, and you can see this is a wave. How, because sin and cos, when it's colliding, by when it have two and the t cos 2t here are bigger, it will create a more dispersed, more like the numbers are very similar, not similar, I mean the differences between them are very small, but will go back to one and go back to one again. So the angle is here is just like this, and the sin is more bigger. So what the difference is just it's an angle inside an angle. It's a circle inside a circle. So that's pretty much it. And how do you control the radius is by there's the equation, the radius and the speed and the time and position. How they control them is like you can just, it's proportion. So if it's bigger, then it's going to get bigger. If you make the radius bigger, then the speed will be bigger, and then the position will be bigger as well. I mean, not the position will stay constant, but the speed will be bigger as well. If you make a bigger circle, like a circular motion, which is a bigger circle, the angular speed will be also constantly proportional with the radius. So how you control is just you just put into this formula, and starting point of motion, the direction, the center, the speed, the radius. If you talking about direction, it's more the positive to the negative. It's clockwise and counterclockwise. You can see by the sign of the speed, sign of the circle equation, and you can see how I control it by through this formula. So that's it for my presentation of my task, and I hope you enjoyed. Thanks.